Why is your brand new condensing boiler actually not condensing? And is there any special little device we can use that can actually help and keep your boiler condensing? Well, if you stick around and watch all this video, that's exactly what you're going to find out. So, let's get on with it. Now, there are actually 3 different types of boilers used in the UK. The most common one is the Combi boiler. Then there's a system boiler. And then there's the heat only / regular boiler. They're the 3 types of boilers, but they're all condensing boilers. So since 2005, all boilers sold in the UK have to be condensing boilers. But what do we mean by condensing boilers? Well, basically what it is the boiler reducing its flue temperature from around about 155 degrees on a non-condensing boiler to lower than 54 degrees for a condensing boiler. So the byproducts of burning natural gas is carbon dioxide and water vapour. So that water vapour turns back into water when we go lower than 54 degrees centigrade, and it turns back into a liquid from a gas. So that's why we call them condensing boilers, because that water then ends up in the heat exchanger, which then goes through the trap and then off to your drainage system. So that's why they're condensing boilers, and they're supposed to be efficient. Now, according to our building regs now, the minimum efficiency for a condensing boiler is 92%. ERP wants us up to over 93%. ERP is the energy rated products now, where this European directive says about the efficiency of all our white goods in our houses. Boilers come under that. But on average, condensing boilers are about 89% efficient, because that is, they have a flow temperature of 70 degrees, a return temperature of 50 degrees, so that makes them around about 89% efficient, not 92 or 93. So, having an oversized Combi boiler, so a Combi boiler too big for your property, is the main reason why your nice new condensing boiler is not actually condensing at all. So let's have a look at a few things and find out what we can do to actually make these condensing boilers actually condense. Now, in this video, I'm mainly going to concentrate on Combi boilers. I'm going to look at heat-only system boilers in another video, which will be coming soon. 80% of houses in the UK have gas boilers. Out of those 80% of homes, 80% of those are Combi boilers. And out of those 80% Combi boilers, probably 80% of them aren't condensing. So why aren't these boilers condensing? Because that's what they say on the tin, they're condensing boilers. So we're going to look at the hot water and central heating that are produced by Combi boilers and see what we can do to actually make the boilers condense and actually save us money and gas and that all important CO2 production. Combi boilers. I want to know which idiot produced a 50 or 54 kilowatt Combi boiler. Who actually came up with that idea? Because it's not needed in the UK market. There is no place for a 50 kilowatt Combi boiler. Combi boilers came into the market because of the small terraced houses replacing the heating system and the hot water from those to create more space in them, getting rid of the cylinder, getting rid of the cisterns in the loft, and making it easier to heat the hot water and the central heating. But they're designed for 1 bathroom, 1 kitchen sink, and small central heating. But when you look at the kilowatt ratings of them, that's not what they're thinking. Now, let's take the central heating first. Now we'll take a 30 kilowatt boiler installed in a terraced house. 30 kilowatt boiler might have 22 to 24 kilowatts for central heating. It's unlikely the boiler will have 30 kilowatts for hot water and 30 kilowatts for central heating. They normally save the 30 kilowatts for the hot water, but we'll get to that in a minute. The average amount of kilowatts required to heat a domestic house in the UK is between 6 and 8 kilowatts. There's very, very few houses out there where you require more than 10 kilowatts to heat the house. Yes, there are some big ones out there, but not a lot of them. So when we're using a Combi boiler and we've got 22, 24 kilowatts of heat there, but we only need 6 kilowatts, that boiler is massively oversized. And that's the thing what's causing us problems and stopping these boilers condensing. There is such a thing called range rating, but most engineers don't range rate boilers down to what they should do. So if we've got a 6 kilowatts required, then we should range rate that boiler down to give us 6 kilowatts. I say give us 10% more for warm up, just to get the house a little bit warmer, a little bit quicker, and give us that little leeway. So instead of range rating it down to 6, you can range rate it to 7 or 8 kilowatts. You could even range rate it down to 10 kilowatts because it's still better than 22, 24 kilowatts. So that's the first problem. The second problem is, because we need 6 kilowatts as a maximum, what do we need when the heating is actually up and running? When it's ticking over, we might not need the 6 kilowatts because not all the heat is going to go out of the house. That might go down to 2 or 3 kilowatts. But there's not a lot of Combi boilers out there will actually range rate down to a minimum of 3 kilowatts. They're all, on average, about 5 or 6 kilowatts, their minimum setting, up to the 22, 24 kilowatts. There's one specific boiler, what I know of on the market, which will go down to 3 kilowatts. Most of the others don't. So that's what you've got to be looking for when you're buying a Combi boiler. What actual kilowatts do you need for the house for your heat loss? The way the heat loss is worked out for a house is a really long, complicated, drawn out process, and I will be doing some videos on those soon for engineers. But if you're a customer, you can actually get your engineer to size your property to tell you exactly how many kilowatts you require for your central heating. And then we come to water. Now some boilers, some Combi boilers out there will give us 15, 16, 17, 19 litres a minute of water going through the tap. Why? For one, that's just wasteful on water, and for two, it's also wasting the gas. Now, because a Combi boiler has 15 millimeters going in and 15 millimeter pipe coming out, really we don't want more than 1.5 meters per second of velocity for the water to go through that boiler. Otherwise, we're going to have noise and it's going to go through too quick that the boiler won't be able to heat it up. So a lot of boilers put restrictors in, but that 1.5 meters a second actually equates to about 13 litres a minute. Combi boilers really shouldn't have more than 13 litres a minute going through them. But have we got 13 litres a minute at the tap? Now my taps at home, they're all restricted to 9 litres a minute, not 13, 14, 15. And the taps here are restricted quite a lot at the centre. I think they're all, a lot of them are 8, 9 litres. So a 24 kilowatt Combi boiler is probably big enough to heat a house and give you enough hot water in most of the houses in the UK. We don't need a Combi boiler bigger than 24 kilowatts, because if we do need more than that, then we should be fitting a system boiler or a heat only regular boiler and using an unvented cylinder to give us the water we require. Also, The bigger the combi boiler, the bigger the gas pipe needs to be. And sometimes bigger the meter needs to be. If you put a 50 kilowatt combi in your house and you've got a 24 kilowatt range cooker and a couple of 10 kilowatt fires in your house, that's got over 70 kilowatts net, and a domestic engineer can't work on those appliances. You're going into commercial. So there are other considerations you need to think about when installing huge kilowatt rating combi boilers. Also, what about the temperatures these combi boilers can actually heat this water to? If you look on the front of most combi boilers, they will take the water up to 60 degrees. We don't need it that temperature. Most showers now are blended to about 38 degrees. Now, if you've got a new build house, your bath's also taken down to 48 degrees. So really, we only need between 35 probably and 45 degrees water. We don't need it any more than that. So again, if your boiler is producing water at 60 degrees and you go up and get in a bath, you're going to be adding cold water. So that means you've wasted even more heat. Also, depending on the combi boiler as well, will it condensate in hot water mode? Well, if you're trying to do 60 degrees of heat and you've got massive flow rates going through the boiler, then maybe you will get it to condensate if the return temperature is lower than the 54 degrees. But if you've only got a low flow rate of water at the tap, why do you need 60 degrees heat? We're just wasting energy and we're just wasting water just because we want to feel nice when we're having a bath. Don't have a bath, have a shower. I very rarely have a bath. I do have a shower every night though. Now I'm going to do a little experiment. So what we've got here is an Ariston boiler which is 24 kilowatts in size. And here we have exactly the same Ariston boiler, but it's a 30 kilowatt one. Now they are both connected to the same water supply and they're connected to the same tap, which is just there. But what we'll have to do is isolate the cold supply coming in to each boiler so they will run separately. So what I'm going to do is I'm going to test the 24 kilowatt boiler. I'm going to see what the flow rate is at the tap, and I'm going to look at what the temperature of the water is coming out, and then I'm going to gas rate the boiler to see how much gas it's using to heat that water. And then I'm going to do exactly the same thing for this 30 kilowatt one and see what the results come out like. Now, because we are just right at the beginning of September and we've had this glorious summer, our cold water temperature, which is most important, is quite high here at the moment. We're averaging about 18-19 degrees on the cold water. So that's the first thing I'm going to test, is my cold water temperature. Because I need my cold water temperature and I need my hot water temperature to work out my delta T, which the manufacturers give us. So, first thing I'm going to do is the cold water temperature. Let's get on with it. Now, what we're going to use for testing this is my weir cup and a thermometer, which most of you will recognise because it's the one you stick up the chicken's bum when you're testing the temperature when you're cooking. So a lot of you will have this, but you won't have one of these. So first of all, I'm going to check the cold water flow rate and the temperature. So if I turn the tap on full, I'm going to put the weir cup underneath the tap and it will tell me on the front here how many litres a minute this tap is doing. I think it's around about 9 litres. So if we look at the weir cup there, it's doing pretty much 9 litres a minute there. Now if you haven't got yourself a weir cup, to be able to work out what your flow rate at the tap is, you need to get yourself a decent bucket. Now this is actually a 10 litre bucket and it's 10 litres till it gets to the top of here. You could probably do this with a smaller bucket, a 5 litre bucket. You'll save water that way. But I haven't got a 5 litre one, I've only got a 10 litre one. So I'm just going to put it under the tap, put it to cold, and I need to get my stopwatch again. And all I'm going to do is open the tap, start the stopwatch, and see how long it takes to fill the bucket up to the rim. So it's on full, started the stopwatch, and it's just a waiting game now. So it's taken 1 minute and 11 seconds, so 71 seconds. So let's go to the board and have a look and see what the math says. So as you've just seen, it took 71 seconds to fill that 10 litre bucket. So the maths is, if we take our 10 divided by 71, that equals 0.140845. We then take that figure and times it by 60, and it gives us 8.45 litres a minute. So you can see my wake up was pretty much spot on with the just over the 8 litres a minute. So if you haven't got a wake up, that's how you can do it. But my advice to you would be, get a smaller bucket, you don't waste as much water. So if I take the thermometer, at the moment it's reading the room temperature of 20.6, and I'm just going to put it in there, and let's see what temperature the cold water is. It's gone down to 19.6. It seems to have levelled out at 18.2 degrees centigrade it is now. That seems to be pretty steady now at 18.2 degrees C. So we've got 9 litres at 18.2 degrees C at the cold part of the tap. So let's try the 24 kilowatt boiler first, and let's see what that gives us. Now I'm going to turn the tap to fully hot, and I'm going to open the tap at full rate to see what flow rate we've got going through this tap. You should hear the 24 kilowatt Combi now fire up. Let's see what flow rate we've got going through the hot tap. So that is looking like 8 litres. You can see that. Looks like about 8 litres is coming out now. And you can see this tap is temperature sensitive, and it is flashing red, as you can see that, so it's telling you it's hot. So again, if I put the thermometer inside the water, we'll see what temperature this gets coming out of the tap here. So we've got a flow rate of 8 litres. We're up to 45 degrees, 47, it's getting up to that 60 degrees, 59, 60, 61, 62. So that seems to be levelling out at 62.6 degrees centigrade. So what I'm going to do now is I'm going to gas rate this 24 kilowatt boiler and see exactly what it's doing in its gas consumption to see if it's getting anywhere near the 24 kilowatts. Because remember, this has a 24 kilowatt output, not an input, but we'll look at all the figures for the boiler later. We're actually going to be measuring the input when we gas rate. Now it's at 61.9 degrees C, so let's get it gas rated. Now this is the meter we're going to be using for doing the gas rating. It's a G4 meter. So I'm going to turn the tap on. I've got my bit of paper and the stopwatch to gas rate it. So let's just reset the stopwatch. So first thing we're going to do is turn the tap on again. Let's move them out of the way. We're on hot. We're still on the 24 kilowatt boiler down there, not this 30 kilowatt one. So I'm going to wait till this gets to a full figure, and then I'm going to start my stopwatch. So 9.370. Five, 56, 57, 58, 59, 2. So 9439. So I'm going to go and do the maths and see exactly what this 24 kilowatt output boiler's input is. If it's lower than 24, then the boiler's coping. But remember, it is summer. Now let's swap these boilers around. So I need to turn that one off and I need to open that one. So now we've swapped the boilers around. Let's do exactly the same thing at the tap here, but with this boiler. So let's do the same thing again with this 30 kilowatt boiler. Let's see what our flow rate is at the tap. So it's on fully on hot water. It was 8 litres before, was it? So the tap's fully on. And again, we've got 8 litres coming out of this tap. So let's see now what the temperature is on the water itself coming out of the 30 kilowatt boiler. So already we're on 33, 36. So we're on 50 degrees. Now remember the other one got over 60, didn't it? It gets to 61 degrees. Seems to be slowing down a bit. 56. Struggling to get up to 57. You can hardly hear the boiler running though. So this is pretty much stabled out at 56.6. So, not gone up to the 60 like the other one did. Well, let's have a look at the gas consumption that this 30 kilowatt boiler is giving us to heat the water to 56 degrees. Now, our 24 kilowatt boiler gas rated at bang on 20 kilowatts net to get that, what was it, 18 degrees water through to 60 degrees. So let's do the same with this 30 kilowatt again. Let's put the tap on. To get my stopwatch again. Again, I'm going to wait till it gets to a full figure. And I'm going to start my stopwatch. So I started at 9.690. So I just need to time it for 2 minutes now. So I'll see you again in 2 minutes. 55, 56, 57, 58, 2 minutes. So 9.753. So let's do the math and see what that comes out like. So let's have a look at the maths for this 30 kilowatt boiler set at 60 degrees. And it came out at 18.3 kilowatts net. But it gave us a temperature at the tap of 56.6. Remember, the 24 kilowatt one gave us bang on 20 kilowatts, but gave us over the 60 degrees C, gave us 62.6. So some of you now are going to be shouting at me going, the 30 kilowatt is more efficient because it's using less gas. But the 30 kilowatt boiler, because it was so big, absolutely struggled to get the temperature close to 60 degrees. It was 56.6. So if you bear that in mind, they're round about the same, there or thereabouts. So I did a different experiment and I took the temperature down to 48 degrees C, which really, that's what we need on a combi boiler. Technically, they say 38 degrees is what we want now at a tap. But 48 degrees in the middle of winter is probably a lot better than 38. So that's what I did. I took it down to 48 degrees. Now, on the 24 kilowatt boiler, I got a flow temperature at the tap of 47.8. And when I gas rated it, it gas rated at 16.27 kilowatts. So that's how much gas it used. Now the 30 kilowatt, bearing in mind I set it at 48, gave me 44.9 degrees C at the tap. So again, didn't get near the 48. It really struggled to try and modulate. At one point, the flow temperature was nearly 50 degrees, and then it really struggled then to try and get it back down to 48 because of the size of the plate and the burner. And that gas rated at 13.65 kilowatts. So again, used less gas, but really struggled to modulate down enough. Now, like I said at the beginning of this video, this is in the summer, or just coming to the end of the summer. We're coming into autumn now, and our cold water temperature is quite high, 18.2 degrees. In the middle of winter, when it's more like 7, 8, 9, 10 degrees, then yes, maybe that 30 kilowatt boiler will heat the water up a lot quicker and a lot better. But at 48 degrees, it probably will still struggle to modulate and could put too much strain on the boiler in that attempt to try and modulate down. So that little experiment has shown a few little things up for me, that the biggest one being that 30 kilowatt boiler really struggled to modulate down with a low flow rate and a high temperature of cold water coming in. I think if you listen to the video, you'd probably hear it going on and off, on and off, on and off, because it was trying to stop the temperature going over the 48 degrees. So let's go to the conclusion for the hot water then. So in my opinion, we shouldn't have more than 13 litres of hot water going through our taps. So if you do check your flow rate at your tap and you've got more than 13 litres, then you can buy the flow restrictors to stop the taps flowing more than that. You can also buy new taps with less than 13 litres on them as well. Because really, we only need about 9 litres of water going through our Combi boilers, and the lower the flow rate, the lower the kilowatts we need to heat that water. So that's the first thing. But if you are adamant about filling your bath in less than 20 minutes, then you shouldn't really have a Combi boiler. You should be looking at a system boiler with priority hot water on an unvented cylinder. And that's what we're going to be looking at in our next video. But I don't know whether you've noticed this little red tin at the side here. Well, this has got my little secret device in there, which is going to massively help people to reduce their fuel bills with very little cost and very little effort to install. So what is it? So I've got the key. Let's open this box and see exactly what it is, what's inside this box. It's this. And if you don't know what this is an outside weather sensor, or commonly known as weather comp. So weather comp, along with a load compensating room thermostat, saves you all the messing you need for your central heating, because this, along with range rating your boiler, will actually automatically reduce your flow temperature on your central heating. It won't adjust your hot water, but it will adjust your central heating. So that's the secret weapon. And if you want to know more about this, then there'll be a video coming soon about it. So hopefully you've liked the video, and I'll catch you on the next one. Cheers.